We are on Chapter 4, Systems of Equations, Section 4.1, Solving Systems of Linear Equations in Two Variables. The first objective we will work is to determine whether an ordered pair is a solution. A system of linear equations consists of two or more equations, and the solution of a system of two equations in two variables is an ordered pair, x and y, that makes both equations true. Let's have a look at this example. It is asked if the order pair -3 and 1 is a solution of the system. And what we're gonna have to do here is just to plug in 3 and 1 on both equations and check if it produces a true statement for both. So let's plug in -3 and 1 on the first equation. -3 minus 1 equals -4. -3 minus 4 is -4. So this is true. Okay, now the next one. 2 times x, 2 times -3, plus 10 times y, 10 times 1, equals to 4. 2 times -3, -6, plus 10, equals 4. -6 plus 10, 4, equals to 4, true. That means both equations, statements are going to be true, and the solution, the ordered pair -3 and 1, is a solution of the system. You can say that it is a solution. Alright, next example. Now we have another ordered pair, 4 and 2, x equals 4, y equals 2. Determine if it is a solution of the system. Plugging the numbers, x equals 4 on the first equation, 2 times 4 minus 5 times 2 needs to be equal to 2. Let's check. 2 times 4, 8. 5 times 2, 10, equals to 2. But we have here 8 minus 10, -2 equals to 2. This is not true. Not true. So it's not a solution of the first. If it's not a solution of the first, it's not a solution of the system at all. Let's just have a look at the next one. Check the next one. 3 times 4, and then I'm plugging in the order pair on the next equation. 4 times 2 equals to 4. 3 times 4, 12, plus 8 equals to 4. 20 equals to 4. Not true at all. That means we can say that this order pair here is not a solution. Okay, let's move on. I think this is quite simple, right? If again, if this is not true for just one of the equations, it's still not a solution of the system. Okay, there needs to be a solution for both equations to be a solution of the system. Next objective, solving a system by graphing. Since the solution of a system of equations is a solution common to both equations, it is also a point common to the graph of both equations. To find the solution of a system of two linear equations, we graph the equations and see where the lines intersect. Let's work this example. Solve the system of equations by graphing. We have two equations. Let's say this one is equation number 1. 2x minus y equals 6, and this is going to be equation number 2, x plus 3y equals 10. Let's draw here a small table where we will have here solutions for equation number 1 and solutions for equation number 2. Let's say if x equals 0, plugging on equation number 1, I will use this as scratch paper for now. By now, 2x minus y equals 6. So plugging 0 here, 2 times 0 minus y equals 6. 2 times 0, 0. Negative y equals 6. Y equals negative 6, right? So y equals negative 6. Now, what about if x equals 1? If x equals 1, let's calculate here, 2 times 1 minus y equals 6. 2 times 1, 2. And minus y equals 6. We can write like y equals negative 6 plus 2, right? Y equals negative 4. Y equals negative 4. And let's say now x equals 2. 2 times 2 minus y equals 6. And remember, what I'm doing here is addition property of equality. Let me do this a bit step by step. This is going to be 4 minus y equals 6. So I can subtract 4 on both sides of the equation. Then we have 0 minus y equals 2, and y equals negative 2 if I multiply both sides by negative 1, right? So y equals negative 2. Now we can graph equation, oops, let me clean this. We can graph equation number 1. First, let's calculate the points for number 2. And for number 2, let's use a different color. Let's use red. Number 2. Okay, number 2 is going to be red. Number 2. For x equals, let's say x equals 1, we will have x plus 3y equals 10. Plugging here x equals 1, 1 plus 3y equals 10. That means y equals 9 divided by 3, 3. What about now if x equals, let's say 4. X equals 4. 4 plus, and you can guess any numbers. I'm just trying to guess numbers that are going to give me integers here when I calculate. 3y equals 10. Remember, what I'm doing here is addition property of equality. Let me do this step by step. Subtract 4 from both sides. 3y equals 6. And divide both sides. Multiplication property of equality. Y equals 2. Right? So here y equals 2. And the next one, let's say now x equals 7. If x equals 7, 7 plus 3y equals 10. Y equals 1. Let's plot the graph. I'm going to plot the graph here. First, let's start with number 1. 0 and negative 6. X equals 0. Y equals negative 6. 1, 2, 3, 4, 5, 6, negative 6 here. X equals 1, y equals negative 4. So x equals 1, y negative 4. Negative 4 is here, right? So this point right here. And x equals 2, y equals negative 2. X equals 2, y equals negative 2. And we have a point here. Now let's connect the 3 points with a line. It's going to be somewhere, something like that. Okay, looks nice. Now, next one, equation number 2. If x equals 1, y equals 3. X equals 1, y equals 3. Next point, x equals 4, y equals 2. X equals 4. 1, 2, 3, 4. Y equals 2. Oops. And x equals 7, y equals 1. X equals 7, 4, 5, 6, 7. Right? Y equals 1. 2 and 1. Now we can draw a line. It's going to be a red line. Let me change the color here of this. I'm gonna use red line. Okay. Connect the dots, connect the points. We're gonna have a red line. Remember that these lines, they're actually going all the way to infinity. They have arrows here, right? On the extremities. Can you see the intersection? It kind of looks like for me is really clear that the intersection is here on this point where x equals 4 and y equals 2. After we find the intersection and find the points, now we have to plug in on the system of equations to check if they produce true statements. Remember the first thing we've seen today? So plug in 4 and 2 on the system of equations, and if you substitute x equals 4 and y equals 2 into the two equations, you're gonna actually, I'm not gonna show here, but you can do by yourself. You're gonna see that you will have a true statement for both, and confirming that 4 and 2, the ordered pair 4 and 2, is a solution for this system of equations. And we found this by graphing. Helpful hint. Neatly draw graphs can help when guessing the solution of a system of linear equations by graphing. This is interesting because sometimes it's difficult to find a solution. You try to calculate using different methods, and then if you graph very carefully, very neatly, you will be able to find out a very good approximation sometimes, or even the exact solution. Another example, solve the system of equations by graphing. Negative x plus 3y equals 6, 3x minus 9y equals 9. And let's try it out here. And the same thing we're gonna do with the colors. Let's use number 1 here, number 1. Equation number 1 and equation number 2. And let's make the the points to draw the graphics. Number 1, number 2. If x equals 0, y equals, and then you calculate here, use addition property, multiplication property, you're gonna find y equals 2. If x equals, and now I'm gonna use x equals 3 and use plug in here, find out the value of y using addition property, multiplication property. Y equals 3. And if x equals, let's say here 6, then y equals 4. Now the second equation, 3x, let's use this as a scratch paper. 3x minus 9y equals 9, right? Then let's try x equals 0. Plug in here 0. 0 minus 9y equals 9. Divide both sides by negative 9. Y equals negative 1. Now let's say x equals 3. X equals 3. If x equals 3, 3 times 3 minus 9y equals 9. 9 minus 9y equals 9. And you can subtract 9 from both sides. At the end you're gonna find out that in this situation here, y equals 0. Let's say x equals negative 3. So 3x, 3 times negative 3 minus 9y equals 9. 3 times negative 3, negative 9, minus 9y equals 9. Add 9 on both sides. Negative 9y equals 18. And this is, erase this. Y equals 18 divided by negative 9, negative 2. So y equals negative 2. Now I can plot the lines, and it's going to be interesting. Check what's going to happen here. First, line number 1, this equation here, number 1. So let's plot the blue line. X equals 0, y equals 2. The point is going to be here. Now x equals 3, y equals 3. X equals 1, 2, 3. Y equals 3 here. And x equals 6, y equals 4. X equals 6. 1, 2, 3, 4, 5, 6. And y equals 4. Then you get the line, draw the line, change color. Let's draw this line here, blue. Okay. And it's going to be something like that, right? Okay. Always remember to draw the arrows so you can visualize that this line goes all the way to infinity in both sides. And now the next equation, the equation number 2, is going to be red. If x equals 0, y equals negative 1. So x equals 0, y negative 1. Here. X equals 3, y equals 0. X equals 3, y equals 0. and x equals -3, y equals -2. X equals -3, 1, 2, 3, -3, y equals -2. And get the line. I'm gonna use a red color now. Red color. Okay. And what can you say about these two lines? They seem to be parallel lines, right? See, 1, 2, 3 units, 1, 2, 3 units. They seem to be parallel lines. One thing that you can do to confirm is to find the slope of each equation. But since the lines are parallel, they have no intersection, so the system has no solution. Solve the system of equations by graphing. Now we have x equals 3y minus 1 and 2x minus 6y equals -2. I can see something interesting on this system, but let's first graph and then we can check it out. Look, we will do kind of the same thing we've done before, right? This is one. Oops, this is equation number 1. We're gonna find values for x, and let's say x equals let me say here x equals 2. X equals 2. Then y equals 1. And I will show here what I'm doing. This is going to be my scratch paper. X equals 3y minus 1. If I plug in x equals 2, 2 equals 3y minus 1. Add 2 on both sides of the equation, right? 3 equals 3y. Divide both sides by 1. By 3, I mean. Then I'm going to have y equals 1. And I'm guessing numbers. I'm trying to guess numbers that give me that will give me integers as a result for y, just to make it easier to work with the graphic. Okay, but you can guess any numbers that you want. You can work with fractions if you want, but I think it's easier to work with integers. Okay, now I'm gonna guess here x equals, to have another integer, that's right, x equals -4, right? If I have -4, x equals -4, y is going to be -4 equals 3y minus 1. Add 1 on both sides. You have 3y equals -3, right? Y equals -1. Y equals -1. And let's say x equals let's say x equals -1. X equals -1. If x is -1, let me clean this up. Oops. Let me clean this, my scratch paper here. Okay. And -1 equals 3y minus 1. Add 1 on both sides. 0 equals 3y, y equals 0. So y equals 0. And look, something that's going to be interesting. Look at that. If now I'm going to try numbers for the next equation. And let's say x equals 2. 2 times 2 minus 6y equals negative 2. 4 minus 6y equals negative 2. Add 2 on both sides. Subtract 4 from both sides. Subtract 4 from both sides. Then you're going to have negative 6y equals negative 6. Y equals negative 6 over negative 6. 1. Y equals 1. Interesting. Same point. Now x equals negative 4. Let's try x equals negative 4. Two times negative 4 minus 6y equals negative 2. Negative 8 minus 6y equals negative 2. So add 8 on both sides. Negative 6y equals 6. Y equals negative 1. Oh, same thing, same point as the first equation, the equation number 1. Next, let's have a look at the next thing there. X equals negative 1. X equals negative 1. So 2 times negative 1 minus 6y equals negative 2. Okay. Negative 2 minus 6y equals negative 2. And add 2 on both sides. We're going to have negative 6y equals 0. Y equals 0. And what can you say? As you can see, what's going to happen here, because as we can see, the other points are kind of similar, are the same. The ordered pairs are the same. If we plot x equals 2, y equals 1. X equals negative 4, y equals negative 1. And x equals negative 2, here, negative 1, negative 1. Y equals 0. This is a line, right? Let's draw this line here. And if we draw the line, the line corresponding to equation 1, what is going to happen? Actually, it are the same points, the same order pairs, and we will have one line on top of the other. There are 3 possible outcomes when graphing 2 linear equations in a plane. The first outcome is to have just one point of intersection. That means there will be only one solution. The second outcome is to have 2 parallel lines, and this is meaning the system of equations have no solution at all. And the third outcome is to have coincident lines, meaning that the system of equations have infinite number of solutions. If there is at least one solution, the system is called consistent. If there is distinct lines in the equations, are called independent. And let's understand. The first example here is one solution with independent equations. The second example here, no solution, is an inconsistent system with independent equations. And the last one, we have infinite number of solutions. The lines are coincident, and consistent system with dependent equations. Now let's work on objective 3, solving a system by substitution. Substitution method is another method that can be used to solve systems of equations. And to use the substitution method, we first need an equation solved for one of its variables. Then substitute the new expression for the variable into the other equation and solve for the other variable. And better to see here an example to understand. Solve the system. 2x plus 3y equals 13 and x equals y plus 4. Since we know that x equals y plus 4, we can substitute this on the first equation and we can write 2 instead of x, we write y plus 4, correct? And let's keep working. Plus 3y equals 13. Work out here the distribution property, distributive property. 2y plus 8 plus 3y equals 13. Combine like terms. We have a like term here, another like term here. 5y plus 8 equals 13. Apply addition property. 5y equals 13 minus 8. It's going to be 5, right? Result, y equals 5 divided by 5, 1. Let me see if I have, we can continue next. And since we know that x equals y plus 4, x equals y plus 4, y equals to 1, right? X equals y plus 1 plus 4, 5. The solution for this system is the ordered pair 5 and 1. Right, and we did this using the substitution method. Step 1. Solve one of the equations for one of its variables. Step 2. Substitute the expression for the variable found in step 1 into the other equation. Step 3. Find the value of one variable by solving the equation from step 2. Step 4. Find the value of the other variable by substituting the value found in step 3 into the equation from step 1. And step 5. Check the order pair solution in both originals. Great. And this is, yeah. Both original equations, sorry. Great. Now jumping to objective number 4. To solve a system using elimination. Elimination is another method. Elimination can be used to solve a system of linear equations, and the addition method is based on the addition property of equality, adding equal quantities on both sides of an equation. The results in an equivalent equation. Let's see here the example. We will solve the following system: x plus y equals 7 and x minus y equals 9 using the elimination method. And the first step, we're going to eliminate y and add both equations. So let me write down here x plus y equals 7, x minus y equals 9. Addition property, add this side of both equations. X plus x, 2x, y minus y, 0. Equals 7 plus 9, 16. That means x equals 16 divided by 2, 8, right? And let's keep working here on this side. We still can use elimination, or you can just plug in 8 on one of the equations and find y. Let's use elimination to exemplify. X plus y equals 7. And then you're going to use the second equation here, but you multiply both sides by -1. Multiplying both sides by -1, you're going to have negative x plus y equals -9. Now you add both equations, x minus x0, y plus y 2y equals 7 minus 9, -2, y equals -1. This is how you use the elimination methods to solve a system of equations. Don't forget to check the solution, and the solution here is the order pair 8 and -1, right? Check this solution into the original system of equations. The step-by-step of the elimination method. The first step, you rewrite each equation in standard form, ax plus by equals c. Then second step, if necessary, multiply one or both equations by a non-zero number so that the coefficient of a variable are opposite of each other. That's what we've done here, right? To have, we multiply by -1 to have x and -x. Step 3, add the equations. Step 4, find the value of one variable by solving equation from step 3. Step 5, find the value of the second variable by substituting the value found in step 4 into either of the original equations. You can do that, or you can keep use the elimination method to find the second variable. And step 6, check the ordered pair in both original equations. Let's work this, another example, so we really can consolidate this knowledge of elimination methods. Solving the system of equations using the elimination method. And we have here some fractions. And one of the things that I think gonna help us is to eliminate first the fractions, right? And we can multiply. We find the least common denominator. We have 3, 4, and 2. And the least common denominator is going to be 12. Okay? Multiply both the first equation and the second equation by the least common denominator, and we're going to find here 12 times 2, so multiply this whole first equation, multiply the second whole equation by 12, then we're going to have first one, 12 times 2, 24, divided by 3, 8, 8x. 12 times 1, 12, divided by 4, 3, plus 3y, equals 12 multiplied by -3, -36, divided by 2, -18. And the second equation, 12 multiplied by 1, 12 divided by 2, 6, 6x. 12 multiplied by 1, -1 over 4, -3y, and finally 12 multiplied by -2, -24. Okay, now we will use the elimination method, and we will add both equations. We will actually apply the addition property of equality, right? We're gonna add 8x plus 6x, 14x, positive 3y minus -3y, 0, equals -18 minus 24, -42. X equals -42 divided by 14 equals -3. And now you can plug in this value that you found for x equals -3, plug in any of the equations, first one or second one. Let's plug in, let's say here, the second. 6 times -3, -18, minus 3y equals -24. And if we keep working here, we're gonna have 3y equals 6, y equals 2. So the order pair solution for this system is going to be -3 and 2. Check, plug the solution into the original system, and the original system is this one here. Okay, plug in the solution here and check if it is true, if it is if it can produce true statement, and then you can confirm it is the solution of the system of equations. Okay, if we check, we're gonna find it's true. This is confirming that it is a solution for the system. Now let's try this different example here. Solve this system x minus 3y equals -2 and -3x plus 9y equals 5. Let's use substitution. Okay, substitution. And this is going to be interesting because now we're going to multiply this first by 3 to be able to eliminate one of the variables, okay? And then 3x minus 9y equals -2 times 3, -6, -3x plus 9y equals 5. Add both sides of the equation, and this is interesting. 3x minus 3x, 0. -9y plus 9y, 0. Equals -6 plus 5, -1. Is 0 equals to -1? No, this is not true. Not true. That means this system here doesn't have a solution, and when we add the equations, both variables are eliminated. We have 0 equals -1. This is a false statement. That means the system has no solution. The equation, if graphed, would represent parallel lines. We're going to have true parallel lines with no intersection. Let's try this other one. We're probably going to see something interesting here too. And we can multiply here on the first equation by 2. Okay, so we will have 4x plus 10y equals 2. And -4x minus 10y equals -2. And if we add 4x minus 4x, 0. 10y minus 10y is 0. 2 minus 2, 0. Oops, 0 equals 0. This is actually true. But that means any x or any y that you have in this system are going to be solution for the system, right? Both variables are eliminated and we have 0 equals 0, a true statement. This means that the system has infinite number of solutions. Infinite number of solutions. The equations, if graphed, will be one line on top of the other, the same line. Okay, let's solve this next example, and we can work using elimination as well. Multiply this equation here let's say we're going to eliminate y, multiply the whole thing by 2, and multiply here the whole thing by 5. Okay, so multiplying this first equation here by 2, you're going to have 8x plus 10y equals 28. Great. And multiply the next one, the whole thing, both sides of the equation by 5. 15x minus 10y equals -5. Excellent. Add, apply addition property of equality here and add both sides of the equation together. 8y plus 15x, 8x plus 15x equals 23x. 10y minus 10y is 0. And 28 minus 5, 23. We can now apply multiplication property of equality by dividing both sides by 23, right? X equals 1. We found x equals 1. We can plug in, you can substitute x equals 1 in any of these two equations. Let's try the second one. Let me bring this here. Okay, 15 times x, 1, minus 10y equals -5. Applying addition property of equality, we can add 10x on both sides. 10y on both sides, 10y on both sides, and add 5 on both sides. And here you're gonna have 20, 0, -5 plus 5, 0, and 10y. That means y equals 20 divided by 10, 2. The order pair solution of this system of equations is going to be 1 and 2. Plug in this on the original system to check if it is, to confirm if it is really a solution for the system of equations.